Hi guys, so I've had a lot of phone calls from very concerned R1 owners this week. Basically, people have been asking me if I can do machining work to fit thrust washers due to the fact that they're concerned they're going to suffer a catastrophic failure caused by the crankshaft coming into contact with the balance shaft as a direct result of end float. So let's start by showing you what end float is. We're in the gifted position here to have a few R1 engines laying around, so I've pulled out a couple of casings here. We've got an earlier casing here which has an aluminium thrust face which controls the end float on the crankshaft, and we have a later engine here which has two steel inserts which also control the end float of the crankshaft. So let's start by showing what crank float is. So this is a crankshaft, this is a set of cases, and I've put a dial gauge on the end here, and you can see if we move this backwards and forwards, we've got roughly 0.2 of a millimetre that this is moving in either direction. So that is called float, and that is directly attributable to the faces that are machined right here on the cases. So the crankshaft itself has two faces machined here and here, which have got big flat edges on them, and these butt up against the machined bearing face on the crankcases with obviously about a 0.2 of a millimetre clearance. This allows it to float either direction by about 0.2 of a millimetre. 2 millimetres, that would be an engineering disaster. By about 0.2 of a millimetre. So we also have a balance shaft. So a balance shaft similarly has thrust faces, which you have here and here, and right here, and right here. In exactly the same way, this can sit in the cases and can move. Let's just show you how much float we've got. So, okay, roughly 0.4 of a millimetre is what we're seeing there. So in essence, in this set of cases, there's roughly 0.6 of a millimetre of combined float between the two shafts, which potentially people are worried will come into contact with each other. So on the later engine, these half moon steel bearing faces are machined into the casing. Now, I think people's assumption is that the early casing has more end float than the later casing, and the reason being that these were fitted which take up the end float and stop that movement. But that isn't the case. The actual aluminium casing is machined back in this area here, and then the steel bearing face fits in there. Now when we do a measurement here, okay, 21.75, and the same measurement here, 21.83. So I mean, there's roughly 0.1 of a millimetre difference in width, and the earlier casing actually has slightly less end float than the later casing. So let's just put the two shafts in together and we'll see how much float there is, and I'm going to do a measurement to show you the amount of clearance that there actually is between the crank web and the web of the balance shaft, because it's pretty large. Just line those marks up. Right, so we've got crank in and balance shaft spinning nice and freely. Now people seem to be concerned that this web here can float in this direction and the crankshaft can float in that direction enough to cause contact. But as you can see, there's a pretty large gap there. Let's actually run some feeler gauges in there. So I've actually already pre-measured this, so I know what the measurement is. So these fit in there quite nicely. That's with me pushing the balance shaft towards me and the crankshaft away from me. Okay, we have a clearance figure in there, 2.47. Okay, I mean 2.47 millimeters in engineering terms is quite a large clearance, and this is at the closest point. So if this web here was to come into contact with the web on the crankshaft, it would have to move another 2.5 millimeters to do it. And the only way that could happen is that either 2.5 millimeters would get machined out of the bearing face that you've got for the balance shaft, or 2.5 millimeters would get machined out of the bearing face for the crankshaft, or a combination of the two. But either way, that's a fair amount of material. You'd probably be finding quite a lot of aluminium swarf in your oil every single time you did an oil change if it was going to happen. So let's put these shafts into the newer engine. Right. Find the marks for the balance shaft. Here we go. Right, so they're both in there. Again, we've got similar amounts of float in both of them. There is actually fractionally more on the crankshaft. So let's bring the webs round and we'll move the crankshaft as far over that direction as possible, the balance shaft as far this direction as possible. And let's run some feeler gauges inside it. Yeah, that's come out the same. Right. That's actually, yeah. Okay. My bearing is. Okay. This is coming in at 2.35 basically. So it's a fractionally tighter clearance with the steel inserts actually machined into it. So there's a lot of material which would have to come out for those two to actually collide. So I personally can't really see any point in machining the cases to fit these, but other people have obviously been asking me about the potential of doing it. So I thought I would show you the measurements and let you draw your own conclusions. Hopefully that clarifies things a little bit.